All right, 4.1, writing equations in slope-intercept form. First, we need to know what slope-intercept form means, and slope-intercept form is in the form y equals mx plus b. And really what we're looking at there is the slope part is the m, that is the slope. We call that rise over run, also known as change in y over change in x, or the equation y2 minus y1 over x2 minus x1. All of those things mean slope, and I guess the other piece you could say is we call it the rate of change. All of those are names for slope. So when I say m, I mean all of that. Okay, or it just depends what context we're talking about it in. And then b is your y-intercept. It's where it crosses the y-axis, where a line crosses the y-axis. The other thing that's important to note there, it's when x equals 0. That's a key piece there. So if you think of a graph and a line that crosses, a line that goes through the y-axis there, that point at which it crosses, let's just say, for instance, that point is 3. It would have the coordinate 0, 3. And so when x is 0, our input 0, our output is 3. So our y-intercept here, or b, would equals 3. Okay. So hopefully that gives us some background. Should be a bit of a review. But whenever you're trying to write an equation in slope-intercept form, the two things you need to know in order to write that equation are m and b. The y and the x and the equals, those things never change. So if I were to kind of write it like this, the y equals and x, those things stay the same. The m and the b are the things that we need to deal with. And note that I put the plus b. That just means the y-intercept's positive in this case. If it was minus b, it would mean the y-intercept is negative. So for instance, on this first one, write an equation of a line with the given slope and y-intercept. Well, that means if my slope is 1/3, that means m is 1/3. My y-intercept is -2, that means b is -2. So what I can do is use my equation, y equals mx plus b. I keep the y and the equals and the x the same. I substitute 1/3 in for m. And I substitute -2 in for the plus b. Okay, and that is my equation. So y equals 1/3 x minus 2. In this one, m and b, y equals 3x plus 7. Okay, remember it's in the form y equals mx plus b. So we just line up those pieces. There's our 3 and there's our 7. Y equals mx plus b. There's m, there's b. Now notice on this one, b is 0. So when I line up pieces, I have my y, my m is -1/2. Doesn't matter where you put the negative sign. And my x. And then plus our 0. Well, excuse me, if b is 0, then notice, really, when you're adding nothing, you can just write it like that. All right. Well, now let's say we have a slope of 0. And that's b there. So we have y equals mx plus b. So we have y equals, now m is going to be 0. So 0x plus -5 or -5 So I have seen students write it as plus negative, and then it just becomes minus. So y equals -5. Okay. And the last one, y equals mx plus b. There's m. There's b. Y equals -1x plus 3. Well, -1x, we usually don't show a 1 when we're multiplying, so we would just write it as -x plus 3. Okay, so like I said, you just need to know what m and b are. So this page kind of gives us a pretty basic what m and b are. Now, in this case, you have to actually look at a graph and figure out m and b. So to write that equation in slope-intercept form, remember you need both m and b. Okay? So what I'm going to do is I'm going to say, okay, right next to each graph, what is m, what is b? All right, and I'm going to have to do this one maybe underneath. What is m and what is b? All right, so in this graph, notice b is my y-intercept. So in a picture, if you can see the y-intercept, perfect. My slope is, well, I rise 1, 2, 3, 4, 5, 6, and I run 1, 2. So I rise 6, I run 2, so that means I have a slope of 6 over 2. Rise over run. All right, so maybe we don't confuse the b there. Let me maybe switch up some colors here real quick. So there we go. B is -1. Okay, and then if we think of the slope 6 over 1, that is, or 6 over 2, excuse me, that reduces to 3. That means I could have rose 3 and ran over 1. And notice I hit the line. Okay, so m is 3, b is -1, so y equals mx plus b. That is going to be y equals 3x minus 1. All right, remember you always start at the far left point. So on this one right here, I'm looking at -3 as my y-intercept. I'm looking at, well, this time it looks like I'm 1, 2, 3, 4 down. So I'm actually going down. If I start at the far left, I'm going down, and 1, 2, 3, 4, 5, 6, 7, 8. So my slope is -4 over 8. Remember, that's rise over run. Okay. In this case, my rise is actually a fall. So that reduces to -1 over 2. So my equation, y equals -1/2 x minus 3. My slope's falling. My last one, my slope is actually 0. My y-intercept is 4. In fact, every point for y is 4. With the slope of 0, y-intercept of 4, when I look at that in slope-intercept form, y equals mx plus b, slope of 0, that gives me 0x, y-intercept of 4. It's just y equals 4. There we got it. All right. Remember, if it's just y equal, it only crosses the y-axis. Okay, the next one, let's go ahead and make it a little more complex. We're now going to write an equation given a set of points. Okay, remember, first we need to know m and b. So, m and b. Now, I made a hint earlier. I said, well, m is, or b is when it crosses the y-axis, or it's when x equals 0. So notice they give us a 0 right here. So if x is 0, that point is our y-intercept. So our y-intercept here is 7. Our slope, well, in order to find that, we're going to have to use the slope formula. So remember, our slope formula is y2 minus y1 over x2 minus x1. And really what that means is if I label my points x1, y1, x2, y2. Now it doesn't matter which ones I call my 1s or my 2s, as long as x2 is with y2 and x1 is with y1. If I label those points, then I can use that formula and plug those in. Remember, this one, our formula up here. So we have our y2 minus y1 over x2 minus x1. Okay, so I'm going to substitute those values in. So that's 3 and 7 and 8 and 0. And notice I use parentheses. That way, if for some reason one of those is negative, like in the next problem, it doesn't hurt us there. So 3 minus 7 is negative 4, and 8 minus 0 is 8, so my slope is negative 1/2. So in this one, I have a slope of negative 1/2, which means my equation I can write now because I know m and b. So in the form y equals mx plus b, then m is negative 1/2, and b is 7. All right, kind of encroached upon my next problem, so I'm going to do that. In fact, I'm going to change up my color here. All right. The next one, knowing m and b. Well, m, once again, is easy because it says it's 0 there. So x is 0, y is negative 2. So, sorry, b is easy. It's negative 2. A y-intercept is negative 2 when x equals 0. So I'm going to make a note of that. Okay, y-intercept or b is when x equals 0. So remember that. Okay, and so on this one, if I'm thinking, once again, x1, y1, x2, y2, another way to plug these things in, substitute them into your slope formula, is you notice I have y2 and it's right above y or x2. So I could take y2 and put it right above x2 in my equation. So I say negative 5 and x2 is right below it. And y1 is right above x1. Notice the parentheses are a big deal there because I get a double negative. And those double negatives are sometimes forgotten if you don't use parentheses. So that makes a plus. So negative 5 plus 2 ends up being negative 3. And negative 4 minus 0 is negative 4. A negative divided by negative, two negatives make a positive. So m is 3/4. So we get y equals mx plus b, or y equals 3/4 x minus 2. Okay. The next one here is a little different. It has it in the form of f of 0 equals negative 4. So f of something equals something. So I'm going to show just a really quick review here. In function notation, remember if I say f of x equals a number, so let's, any number, this is my input. This is my output, which means another name for x, or input, is x. Another name for output is y. So really in this format, in function format, really all they're doing is giving you another ordered pair. They're saying, okay, when x is 0, y is negative 4. That's what this says. This one says when x is 2, y is 10. So knowing that, we now have 2 points, just like we had in this previous problem. Here's x1, y1. Here's x2, y2. And we can find m, and we can find b. M is a little tougher to find, so let's find b first. It's when x is 0. So b is negative 4. M, we're going to use our slope formula again. And I really like that deal where we just make it into a fraction. We say, hey, y2 goes over x2. The guy that I teach with, Mr. Vogel, actually showed that. It's a nice way of doing it. So 10 over 2, and then negative 4 over 0. All right, and then the two negatives, that's a big deal. That makes a positive. So 10 plus 4, good buddy there, is 1, 4. And 2 minus 0 is 2, which gives me 7. Slope of 7. So y equals 7x minus 4. Okay, and then that last one there, I'm hoping that sometimes you guys are just pausing it and trying them before I try them, but that last one, I'm going to have the ordered pair 0, negative 1. Okay, there's x, my input, my y output, and then 3, 8, x1, y1, x2, y2, m equals b equals, well, b is negative 1 because of the y-intercept. It's when x is 0. Okay, my y2 minus y1, make sure your y's go on top. So 8 over 3, negative 1 over 0. There's that double negative again. I put a few of those in there to make it so we'd see that. Okay, that becomes plus. So 8 plus 1, 3 minus 0. So slope of 3. Y equals 3x minus 1. All right. Hopefully we got it. Hey, one last thing here. Using mx plus y equals mx plus b in word problems. When we're doing that, just note that when we're dealing with it in word problems, that format, usually your slope is a rate. And we can identify rate by the word per a lot of times, like per hour or per gallon or per second or something like that. That's a rate. Sorry about that. Our B term, when we're dealing with it in a word problem format, is our initial amount. An initial amount is your beginning amount or starting amount. Okay, so you can think of it as starting amount. So sometimes that could be like a fee, like a one-time fee, or a cost to enter somewhere, and then you get charged per hour. Like if you're going to I don't know, like a trampoline park or something like that, you have to pay $5 to get in, and then like $2 an hour. Your $5 would be your initial amount. Okay, so in this story problem, an appliance repair company charges an initial fee of $70. So automatically, if we understand this equation and these pieces, we know that our initial fee is B. That's our y-intercept. And then it says, and $110 after 4 hours of work. Well, after 4 hours of work, another way of saying after is like saying per. Okay? So we could kind of get rid of that word after and say, well, that's $110 per 4 hours. Well, that really, the word per in math means divided. We think of it as divided by. So what I could do is I can say, okay, hold on. M is and B is, well, B is 70 and M is 110 per 4 hours. So $110 per 4 divided by 4. Okay, so if I wanted to actually calculate this, it says write a linear equation for the total cost of the function as a function of the number of hours worked. Well, my total cost is going to be reliant upon the number of hours worked. So T of H, okay, the total cost is reliant on the hours worked. So we're going to call total cost T. We're going to call hours worked H. Okay, so T of H is going to be equal to M times H plus B. Now, I could have lost some of you right there by going, you're like, whoa, hold on, what happened to y equals mx plus b? Well, remember, we still are in y equals mx plus b, so maybe let me back up just a little so I don't totally confuse you. Okay, total cost is a function of hours. So if we think of our form y equals mx plus b, okay, our total is going to be reliant on the hours. So our dependent, like t is dependent, just like y is dependent. Hours is independent. Mostly time is almost always independent, just like x is independent. So t equals m times h plus b. I'm just replacing x with h, y with t. And then I'm writing it in function format. So I'm saying t of h. So the total is a function Okay, so that's all I did first, because it said write a linear equation and it has a function here. So I thought I'd put function form. Okay, so in this case, I would say, well, m is 110 over 4, so t of h is equal to 110 divided by 4h plus 70, our b term. Okay? So some of you may go, well, can I divide those? Well, yeah, you could. 110 divided by 4, well, that's 27.5. So you could say, well, t of h is equal to 27.5 h plus 70. And notice if I actually reduce this, this becomes 27.5 over 1. Well, remember what this means. This was dollars per hour. So this was $110 per 4 hours. Well, now this means $27.50 per 1 hour, which is good because that's actually our rate. That's how much we're getting charged an hour. So what is the total cost per hour? Well, it's $27.50 per hour. Okay? All right. If that confused you with the T of H, then what I would do if I were you, I would just start it out in this format right here. I'd say, hey, y equals mx plus b. And m is 110 over 4x plus 70. And that's equal to y. And then you could replace it. You could say, okay, well, I'm going to put t in for y. I'm going to divide the 110 by 4 to get 27.5. And I'm going to put h in for x. Okay? And then maybe you don't have function notation. You just have your linear equation, which would be fine as well, because technically it just asks for the linear equation. I just put the function form because we're talking about function, trying to relate it to previous stuff. All right, hope that helps. Good lucky.